Right on time. Okay, thanks. Whoops. Okay, thanks so much for coming. And earlier today, I don't know how many of you were here for Moan's and Iggy's opening session, the cold opening and such. But among the things that were mentioned there was going to be the impacts of some of the new regulations that are coming down. This is one of them. This is basically a new, shall we say, a new job role, if you will. It could be a part of everyone's existing job, yet add another log to the fire. But chances are good it's something that's new and is coming along. And the thing is that security is an issue. Everybody is finding themselves perhaps up on the data breach wall of fame. And you know, it started off maybe 10 years ago, at least hitting the news in a big way, but starting around 4 years ago, it really started multiplying, coming faster and having bigger and bigger breaches. More and more companies, blue chip type companies, ending up on the wall of shame, if you will. And what's the problem here? Why aren't they able to secure their systems? What is it that is causing them to end up on this wall of shame all the time? And the fact is that they have a pretty bad attitude about security for the most part. We have a firewall and we're good. That's all we really have to worry about. And the question is, oh, really? Okay, so let's look at history. I mean, you know, history doesn't guarantee what's going to happen in the future, but back in the 30s, France, just, you know, a few years out of World War I, the war to end all wars, built something called the Maginot Line on the border between France and Germany, because that's where the attack was going to come from. That's what we expected. It was designed specifically to be formidable and impenetrable as far as Germany was concerned. So it was impregnable. And even the military experts that were consulted on them, you know, agreed that the Maginot Line was going to absolutely prevent anybody from passing. So this is what happened. We have the Maginot Line. Why fear Germany? You know, because that's where the line was, right on the border. Germany said, hold my beer. You know, they defeated France in 6 weeks. That's because they did the unexpected thing. So if you go back to that slide earlier where I showed all the data breaches and why they started to really take off around 2014 or so, is that's when they started attacking non-prod, right? Because you expect prod, production environments, that's what runs the business. And that's what's hardened. That's the Maginot Line, okay? But non-prod, it's actually a much larger portion of our environment, but not as well protected. But it's got, for some reason, all of our confidential data in it. And that's because of the way we do software development. The way we do software development is we produce our dev and testing environments as copies of prod. Okay. So production gets all the attention. You know, if you think of your systems as an iceberg, I know it's a cliche, but even so, if you think of your systems as an iceberg, prod is what's above the surface, the visible thing, the thing you are inclined to protect. But in reality, for every prod, there's a dev system, a SIT system, you know, system integration testing, there's user acceptance testing, etc. It's a much larger surface area to attack below the surface of the iceberg. I wouldn't want to go attacking an iceberg, but you get the analogy there. You know, users, application users use prod, but the users that use non-prod are developers, testers, a different community of folks. We can't secure the same way as with prod, because with prod, we secure through the application. But with non-prod, these are people who might not necessarily, who are these people? Developers, testers. They might not be employees. They might be offshore outsource folks. They might be, it could be that your systems are actually somewhere else in the cloud. There are countries that have regulations against data leaving the country. And with cloud systems, those country, you know, companies in those countries have a big problem. So the solution for production, for the most part, especially for securing data, has to do with either encryption of the data at rest or redaction, which is also known as the masking of data in flight. In other words, retrieving the data, changing it in flight before it gets presented. That works really, really well, and there's a lot of good solutions for that. Oracle has DBMS redaction. Microsoft has their own masking product that's built into the database. But for masking at rest, what should we do? And stop and think, this is a huge problem for all of us. I mean, the best vector for us to get to the cloud is in our non-production systems. That's where we need expandability, instant expandability and such. That's where we need to use the cloud, is our non-prod systems more than our production systems. Yes, those will eventually get there, but there's all kinds of amortization that has to happen to let the hardware that they've already invested with on-prem to go out of, to die, essentially. So we need to get our non-prod systems up to the cloud. But the non-prod systems have all this data, and that's what's actually preventing people, the sensitive data, preventing people from getting it up to the cloud because they're so afraid of data breach. So what can we do about it? And the answer here would be remove the value from that asset and protect what's really important. Not to draw the analogy too far, but France ought to just, abandon the rest of the country and protect Paris. Well, that's not quite the same thing. That's not exactly what I'm saying, but protecting Paris is important. Protect production is important in your systems. So what's been protecting data in our environments all along, and that is the honor code. I think you're all familiar with it. Absolutely, we're all in this industry. There is an honor code, and it has to do with, we have to protect the data because we're professionals. We can't breach, we can't do that. Basically, that all took a big hit back in 2013 when Snowden came out. Edward Snowden did his bit, right? My kids thought Edward Snowden was the greatest thing, a real hero, stick it to the man, the whole thing. I couldn't stand the guy because he broke the code. He broke the honor code. And all of us here are still probably, a little bit miffed about that. So with all these regulations, GDPR, now, GDPR, as soon as it became a thing in 2014, you knew it was going to come across the pond to the United States, and it sure is, starting with CCPA in California, which is due later this year. The honor code is no longer sufficient. It's not enough to be unwilling to breach data. Nowadays, to protect yourself, you have to be unable to breach data. So the whole upshot is we need to obfuscate the data. Oh, these are slides I wish I didn't have for a 10-minute session. One of the things we need to do is first identify the data that is confidential within our systems. That's not an easy thing to do. Everyone thinks they know where the confidential data is, but you need a method to profile and find. I'm just going to blow through this slide because I don't want to spend too much time on it. What I do want to spend time on is what's the difference between true masking and just simply scrambling data. You can't just scramble it. You can't damage the data. You need to actually change it in a read consistent, but referentially in a way that preserves referential integrity. So here's a method that's better than just simply encrypting. We call it the secure lookup algorithm. It's one of 8 different transformation frameworks that are built in. It's proprietary, but it's easy enough to talk about. And the whole idea is to take data from a replacement table and replace it over the real data. Okay, so that way you're using data that looks good. So when we use that replacement algorithm, we have to choose the right values and choose them consistently so that whenever we have this input data, we always have this output data from that replacement table, regardless of whether it's on Oracle, SQL Server, in a PDF, etc. So an example is, let's say I have a source table with company names. I have 1,000 distinct values. And I have a lookup table that has fewer than that. That's important for the algorithm. Fewer than 1,000 distinct values. I have 500 distinct values. So let's say I have a company name of Engulf and Devour. Melworks fans here? Anybody? First thing I'm going to do with this algorithm is I'm going to encrypt it. It's going to come up with a garbage string as part of encryption. And you're thinking, well, encryption, that's good. Well, yeah. But remember, encryption can always be cracked. We need something that can't ever be cracked. That's what we're trying to do, is obfuscate permanently and irreversibly. So encryption is the first step. The next step is to take an MD5 hash of that encrypted string and convert it to a number. The last thing now is what makes this irreversible. Okay? We have a table of replacement values. Nobody else knows how big it is. We do. We modulus that hash value from the encrypted value and come up with an index into our lookup table. And that becomes our replacement value. And another thing that's important about that replacement table is that the data in it is slightly off. In this case, Amazon with 2 Z's. You could tell that it's a masked value, but it still looks good enough to use in training materials. It looks valid enough, but it has no relation whatsoever to engulf and devour, or does it? That was a joke. At any rate, so masking, and then the last thing that has to be done when we look at this task of masking is making sure that whatever we masked did get masked, and if we're being polluted with actual data after the fact. So there has to be an auditing capability to your masking. So profiling, actually masking, and auditing. It's 3 big jobs. It's really a new job role. Okay, there's a couple gotchas. Masking, at least currently at rest, is always performed by SQL statements. Well, heck, you know, you've seen a lot of people present on this stage here and on other stages about how to recover transactions, you know, data recovery mechanisms built into Oracle or other databases. Those have to be defeated. You have to, you know, you have to do it in such a way to defeat those things. So Oracle has like log miner. You have to figure out how to defeat it, like switching off archive logging and switching out the contents of online read log files. Disable flashback. Make sure you disable trigger logic that might be creating custom audit trails, et cetera, and so forth. AWR, clear it out. Other gotchas, they're bound to be, okay? But once you've done that, as long as you understand what the different obfuscation options are and what they're appropriate in, you can move forward. Encryption and redaction are good for production. You always need that kind of support in production. But encryption doesn't help you in a non-production environment in dev and test, because as soon as you have the decryption key, it's all over. What you need to do is permanently change the data so it's no longer the same. Then you can take that database and you can put it anywhere you like. That's the whole point behind this field. And there are a couple job titles that didn't exist 2 years ago. They sure exist now. Go check Indeed. Data masking specialist, data protection, vulnerability management specialist. It's a green field. The tools that are out there now are okay, but they're certainly not in their final form, okay? So I work for Delphix. Delphix is one of those tools. IBM has 2 solutions in this area. Oh gosh, and now it just cleared my mind what they're called. DataStage and Optim, IBM Optim. Informatica has a data masking tool, very similar. There's another vendor called Data Veil, V-E-I-L, not like the other company, Data, V-A-I-L. But there's a lot of good solutions here, and there are more good solutions that are coming down the pike. But if this is something that you think you can do by just doing a very simple shuffle algorithm, it's not possible. You really, this is an area that everybody needs and every company needs. So that's all I've got, and thank you very much.